Hello and good day to all of you. So in this video lecture, we are going to learn about the origin of Earth rotation and also the revolving of the Earth. And also we look at what are the reasons which is affecting to slow down the rotation of the Earth. So before starting the lecture, we have two learning outcomes for this piece of lecture. So the first objective is to learn and understand the Earth rotation, revolution, and also the tilt angle, how much is tilted, and what are the effect of this rotation and revolution of the Earth. And also we'll understand why the rotation is being slowed down and what are the two factors which most probably affect the speed of Earth rotation slowing down. So this is a big picture of the Earth rotation. So you can see the Earth is rotating. If you look at from the North Pole, so you can see it is actually going to the anti-clockwise. So let's look at the origin of the rotation. So origin of rotation, there's a lot of theories have been presented, but if you look at the Earth when it was formed as a part of the birth of the solar system, obviously 4.6 billion years ago, it was composed of hydrogen and helium, which was produced in the Big Bang time, and as well as the heavier elements which was ejected by supernova. So this was the time when there was a Big Bang. So when it was forming, and there was actually the angular momentum, initial angular momentum, which need to be conserved, the clustered mass starting rotating faster. So you can see when there was a Big Bang, then it started to become by the angular momentum. From there, it threw some of the debris, but the sum of the object which was quite larger. So when it was obviously the solar system and was forming, and together with solar system forming, all the elements or the solar system, including the Earth, was in the form of initial rotation. And also the other factor including the tidal frictions and also the hypothetical impact of Theia. So this is the actually origin of the Earth rotation and revolution. So if you look at the rotation period and how we can measure the rotation period of the Earth, so the permanent monitoring of the Earth rotation require a very long baseline interferometric coordinates with the global positioning system and also the satellite laser ranging and other satellite techniques. But there is a formula which is known as T is equal to D over V, where D is actually the distance in case of the circumference, and V is the actually tangential velocity of the Earth. And this can provide the absolute reference of the determination of the universal time, precision, and notation of the Earth rotation, how it's going to be rotating like this one. So there's two terms which I use. One is rotate and the second one is revolve. So rotation is actually referred to the movement around its own axis. So let's say this is the Earth and how it rotates. So it's rotating on its axis. So how much time it takes to rotate is actually take 24 hours or we can call it 1 Earth day. And this actually, the purpose of this rotation is, or the effect of this rotation is, we can observe day and night. So let's say every 24 hours you have the day or the night. So this actually causes the effect of the day and night. And the second thing is revolve. And revolve is actually terms which used to move in a circle or on a central axis. So the sun is actually not in the central axis, but somehow it's in a central axis, so we can consider this is the sun and the earth is revolving around this sun. So how much time it takes from this point complete one cycle is actually 365 days plus minus. which is equal to 1 year. And what are the cause or the effect of this rotation revolution is the seasonal changes. So we have, in some region we have 4 season, 3 season, or 2 season. So this is because of the earth revolutions. So now we look at the angle of the tilt. So you have been observing that everywhere you can see the globe is actually in this tilt form. So why it is like this? Actually, it represents the actual orientation of the our Earth. So let's look at more into detail. So let's say if it's a perpendicular to the orbit, so which is this one, and when we observe the angle from the tilt angle is actually 23.5 degree toward the east, toward the west actually. Yeah. And obviously the equator, which is the celestial equator, is over here, but this is the orbital direction of the Earth. And also we have talked about the North Pole, magnetic North Pole and South Pole, and also the North Pole or the South Pole of the Earth is also different, which is 11 degree tilted toward the east, toward the west. Yeah. So this is now clear that the Earth is tilted actually 23.5 degree toward the west. So what are the evidences of the Earth rotation? Obviously, we can't see the Earth is rotating. Obviously, we are not in satellite, but obviously there is a lot of technologies which makes you possible that which is actually Earth is rotating. So one of the observation is actually if you know the Coriolis effect, which actually the falling bodies change the direction eastward from the vertical plumb line below their points of the release. So if you look at the Coriolis effect, so similarly this is happening at the Earth. So the object which fall in the northern hemisphere that deflect right in the northern hemisphere. So if the objective is here, because Earth is rotating in this dimension, so this will deflect toward the toward the right. But the object which actually fell down in the southern hemisphere, so these object actually deflect toward the left in the southern hemisphere. So this is toward the right and this is toward the left. Why? Because of the rotation of the Earth. So what are these objects I'm talking about? Actually, these are the object, especially when we have some meteorites, asteroids, which is hitting to the surface of the Earth. So when they enter to the orbit of the Earth, then they deflect toward left or right in the northern and southern hemisphere. So there is a theory which is presented by the Nathaniel in March 13, 2021, which was from the newsletter. So he stated that the Earth rotation is gradually slowing down. So he stated that the length of the day, which was about a million years ago, was shorter than today. So it's been that time the Earth was rotating faster than today, because he mentioned that the day is shorter than today. So it's been it was faster. So now the speed of the Earth rotation is gradually going down. So he also further explained for billions of years the Earth rotation has been gradually slowed down, and it is a process that continues to this day. And estimators suggested that the length of the day currently increase by about 1.8 millisecond every century. So this was his prediction. So based on that, also we can look at some evidence how the Earth rotation is going to be slowed down. So the first thing also we can look at why the earth is spinning, slowing down. So the first reason, it is because of the moon exert the gravitational pull on the planet. So if this is toward the moon, and obviously it has some gravitational attraction, so this exert the gravitational attraction to the moon, to the surface of the earth, which cause rotation of deceleration since the moon is gradually pulling away. And also the second effect is we have observed the tides, which actually the tides also producing because of the moon. So obviously there is some gravitational pull on the surface of the earth. So for billion of years the moon has been covered. So for billion of years the moon has been ever so gently tugging at the earth and slowing down the rotation. So this is one of the cause that moon is exerting the gravitational pull on the surface of the earth. And the second reason of slowing down the spinning of the earth, there's a lot of models which predicts that the earthquake should have affect the rotation of the earth by shortening the length of the day by about 3 microsecond, or the 3 millionth of the second. So this happened because of the during of the earthquake, one of the plate, that is obviously the Indian plates we are going to present, and the subject beneath the another plate, which is the Burma plate, so which is actually referring to the earthquake which was happened in 2004 in Sumatra. So one of the reason of the rotation is significantly slow by the gravitational attraction of the moon, and also the tidal which we have discussed. So however, there is some large scale events such as mentioned is 2004 there was an huge earthquake which was here in 2000 Indian Ocean earthquakes, and it has caused the rotation speed slow down around 3 microsecond. So this is also another reason we have. So the first reason is the moon gravitational attraction, and the second reason is the earthquake. But obviously the large earthquakes, not the small earthquakes. Okay, with that's all. Thank you so much, and I hope you have learned about this rotation and revolution of the earth, and also what are the effects of this, and also why the spinning of the earth is slowing down. So we have presented two reasons. If you have some further reasons, so you can further comment in the video comments box, and also you can give your suggestion what are the other effects can be used or can be effect on the spinning of the earth rotation. Okay, with that's all. Thank you so much and have a good day.